Hello, today we're going to talk about evaluating polynomial functions and describing in behavior. So our objective, of course, is to evaluate and graph polynomial functions. A polynomial is a monomial or sum of monomials. Basically, they're going to look like a quadratic, but you're just going to have more terms. In fact, a quadratic is a special kind of a polynomial. It's just now we may have x cubes, x to the fourth, x to the fifth. The exponents can be any whole number, and so linear functions are actually special cases, and so are quadratics. And the leading coefficient is what they have marked here as an. If you have your polynomial in standard form, it's going to be the first coefficient, which is why it's called the leading coefficient, and then the largest exponent is the degree. Way at the end is going to be your constant term. All right, so we talked about there are constant functions. That's something like f of x equals 3 or y equals 3. A linear function would be like y equals 3x. A quadratic would be y equals 3 squared. Cubic, y equals 3 to the fourth. Quartic would be Cubic would be y equals 3 to the third, and quartic would be y equals 3 to the fourth. So the first thing we want to review is how to evaluate polynomials. And so if I have f of x equals 2x to the fourth minus 5x cubed minus 4x plus 8, and I want to evaluate it when x equals 3, that means substitute and simplify. So in the original function, everywhere you see x, you're going to plug in 3. So if you'll notice over on the left-hand side, sometimes there's some confusion about this. One of the advantages of function notation is that we can keep track of what x value we're evaluating for. We can write it as f of 3. This does not mean f times 3. If we wanted 3 times f, that 3 would be out front. This means the function f with 3 as the input. And so everywhere we see x, we're now going to put 3. So at this point, after we substitute in the 3, there's no more variable x's. We're looking at the case where x is 3. So we have 2 times 3 to the fourth minus 5 times 3 cubed minus 4 times 3 plus 8. And now we just simplify. So we're going to have 2 times 81 minus 5 times 27. We can go ahead and do 4 times 3 is 12, and then plus 8. So 162 minus 135 minus 12 plus 8 is going to give us 23. So f of 3 is 23. So for this function, when we input a 3, we output 23. Some polynomials, we'll need to be able to evaluate some points, figure out some ordered pairs, plug in some x's and generate some function values, but we also need to know what's happening at the ends of the polynomials. And we call what happens to the far left and to the far right the end behavior. So formally, this is stated: the end behavior of a function's graph is the behavior as the graph as x approaches positive infinity as we go far to the right, or negative infinity as we go far to the left. And so we have basically 4 cases whenever we have polynomials. If the polynomial has an odd degree, if it's a linear function, if it's a cubic function where you have 3 as the degree, if we had something with x to the fifth, all of those would have odd degrees. Even degrees are things like x squared, x to the fourth, x to the sixth, and so on. All right, so for odd degrees, the two ends, as we go to the left, as we go to the right, are going to go in opposite directions. You're going to have one that goes down and one that goes up. When we have an even degree, everything's all even, and both ends either go up or both go down. So how do we know what case we have? Well, once you've figured out whether the degree is odd or even, so that's from the exponent, you shift your focus then to the leading coefficient. And if that leading coefficient is positive when you have an odd degree, that means that you are going to go down to the left and up to the right. If that leading coefficient is negative, you would go up to the left and down to the right. If we have an even degree and the ends are going to go in the same direction, if the leading coefficient is positive, it's going to be where both ends go up. That corresponds right to what we were talking about with quadratics. That for quadratics, if A is positive, and that's our leading coefficient, then it's going to open upward. So both ends will go up. If the leading coefficient is negative, both ends will go down. Okay, so we're going to describe end behavior for 4 different functions. And I'm going to keep this little graphic for us so we can see which case we're talking about, and that will help us answer the question. So it says, describe the end behavior of each polynomial function, and we've got each function listed. Let's look at the first one. Let's look at f of x equals 3x to the 4th minus 5x squared plus 1. We don't really care about the other terms. We just care about this first term. It helps to do a quick scan, just make sure it's in standard form. It is. I've got my highest degree here in my first term. So the degree for this polynomial is 4. And so that means I have an even degree. Okay, so I'm going to be over here where the even degrees are. And then I have a positive leading coefficient. So I look over here and go, oh, if the leading coefficient is positive, that means I'm going to go up to the left and up to the right for my 2 ends. Easy. Let's look at the next one. We have f of x equals negative 3x to the 4th minus 5x squared plus 1. Again, it's in standard form. We ignore the other 2 terms. We just look at this first term because that's going to tell us what the end behavior is. And we've got x to the 4th, so that's still an even degree. But this time, our leading coefficient is negative 3. So we're on this case over here where the left end is going to go down and the right end is going to go down. So we've got down to the left and down to the right. For part C, we've got f of x equals 3x cubed, blah, blah, blah. All we care about is that first term. We have an odd degree. And then we have a positive coefficient. So odd degree, positive coefficient, so that means it's going to go down to the left and up to the right. And finally, we have f of x equals negative 3x cubed, on and on and on. We just care about this first term. So the degree is odd, and we have a negative coefficient. And so odd degree negative coefficient means that we go up to the left and down to the right. Okay, you're ready to do the problems to try on your own. We'll go over those in class, and I look forward to seeing you then. Have a good day.